Okay, we have practice with rounding, and in this case, we are rounding the values to 3 significant figures only. So let's figure out where that's at. So 1, 2, 3. So this will be rounded to, let me just go ahead and highlight. So this is rounded to this value, 1, 2, 3, 1, 2, 3. Okay, so these are the values that we need to round. All right, so the first one, if we were to round this value, because we're going to have to round up, then this whole thing will turn into a billion. So how do you write this in? So, because you can't just put, because then that does not fit the 3 significant figure, it's just going to be a 1. You cannot put a decimal point at the end because then that means all these zeros will count. So if you run into that kind of problem, then you can turn this into scientific notation. So we're going to have 1 point, and then we only need 3 sig figs, so that would be 2 zeros times 10 to the 9th. So that's how you get around with examples like this, wherein if you can't write it the normal notation and have the right sig fig values, you can just turn it into scientific notation. Okay, up next we have this value, so the 8 will round up. So we get 3, 2, and then 8 will turn to 9. Okay, now, if you end here, the 32,000 will become 329. They're not quite the same values, and so you have to turn the rest into zeros to make that number its original value. So this is 32,900. You don't have to worry about these zeros because they don't count anyway. Unless you put a decimal point, then we're going to have 5 sig figs. But in this case, we only have 3. Okay, we have 2.90, and it's actually this 0 right here. So we have 2.9, and because it's just a 0 next to it, it would just be 2.90. Okay, now what happens if we do the same thing with what we did on top? Turn everything into zeros. So we have 2.90, 0, 0. They're the same number, but it's not going to be the same sig figs. This has 3, this has 1, 2, 3, 4, 5. So this cannot be your answer. Okay, so always be mindful of that when you're working on these kind of problems. Okay, up next we have 5, 6. So this one will turn into a 5, and yes, you do have to write in the leading zeros. Because if you go straight to 5, 6, 5 again, this is in decimal. This one is 5, 6, 5. It's not the same value. And if you decide to add in the zeros after, so 0, 0, again, it's the same number. However, it's not going to be the right amount of significant figures because now these zeros will count. So again, do not make that mistake. Next we have 3, 4, 9. So this will turn into 5 or 3, 5, 0. And if you end there, again, it's not going to be the same value. This is 349,000. This is 350. So then go ahead and turn the rest into zeros. Okay, now we run into the problem of this does not have the right significant figures because if we keep it like this, even though the answer is correct, it doesn't have 3 sig figs, it has 2. So then we turn it into scientific notation. 1, 2, 3, 4, 5. So our answer is going to be this instead of that. Okay, now we have 10,000, and to have it to 3 sig figs, we can't just leave it like this. So it's going to be 1.00 times 10 to the 4th. And we have this value, so it's going to be 1.76 times 10 to the minus 4th. And so that's how you round numbers according to the sig figs given to you. Again, the point is that if it doesn't work as a standard notation, go ahead and turn it into scientific notation so that you have the correct numbers of significant figures. We also have rules for rounding when it comes to calculation. So from this point on, since we've already covered, or we're covering, significant figures and rounding rules, all your answers need to consider significant figures and then the rules that go with it. So the first one that we're going to cover would be rules when we are multiplying and dividing numbers. Round to the same number of significant figures as there are in the measurement with the fewest significant figure. So at the end of our answer, and again, we're only rounding the final answer. We are not rounding while we're still in the process of calculating. We will only be rounding the final answer. And when we're multiplying and dividing, if that's the last thing that we're doing, we will round our answer to the fewest number of significant figures. For example, let's say we are calculating for volume and we have 9.2 centimeters times 6.8 times 0.3744. And if we enter this in the calculator, we will be given 23.4225. Now, if you report this answer, if you report all of the numbers that are present in your calculator, technically you're correct. But in terms of significant figures and measurements and the rules that we are going to be talking about, it won't be counted as a correct answer. So again, when we are multiplying or dividing, we will need to round our answer to the fewest number of significant figures. So we're going to go through each of our measurements and we're going to count the number of significant figures. So for 9.2, we have 2 sig figs. 6.8 has 2 sig figs. And 0.3744 has 4 sig figs. So the lowest or the fewest significant figures in all of our measurements will be 2. Therefore, our final answer, this 23.4225, needs to be rounded so it only has 2 significant figures, and that would be just 23. When we are multiplying and dividing, we are looking for rounding it to the least amount of significant figures. So that's the first thing we're going to do, starting with sample 1. Okay, we have 3.4617 times 10 to the 7th divided by this value, and this one has 1, 2, 3, 4, 5, so this has 5 significant figures. It has 1, 2, 3. So because we're looking for the least amount, our final answer needs to be rounded to 3 significant figures. Okay, let's enter this in the calculator. 4617. Okay, our value is going to be I'm going to go ahead and enter extra digits. And then we're going to round it afterwards. Okay. So this is what the calculator gives us. And then I will expect that you know how to handle units. Okay, so grams and centimeter cube cannot cancel out, so we're going to have to write both of those in. Alright, so this is not going to be our final answer. We do have to round it to 3 significant figures, and so that would put us at 1, 2, 3, so we are rounding here. So our final answer should be 6.17 times 10 to the 10th. That is grams per centimeter cube. Alright, next sample. Okay, we have 1, 2, 3, so this has 3, oh, sorry, not 3, we have 4 sig figs, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So it looks like the least amount is going to be 4 significant figures at the end. Alright, let's enter that in our calculator. So we have 9.714 times 2.1482 to the minus 9th divided by these values at the bottom, and it looks like we have to multiply. So 4.12 times 3.7792. Okay, my final answer is 13.39828601. Okay, now we have to figure out what we do with our units. So we have meters and meters squared, so that gives us meters cubed. And then we have meters and second, so they're not the same letters. So we're going to have to do m.s, but the m's will cancel out, so it looks like we're going to cancel out one of the m's. So instead of third, now it's just going to be to the second. Okay, also, we only need 4 sig figs, so that would be 1, 2, 3, 4. So we're going to have to round it to that value. So our final answer is going to be 13.40, and that's still the right amount of sig figs because that 0 will count. It's after the decimal point. And our units are going to be meters squared per second. Okay, last example. Okay, we have 1, 2, 3, 4, 5 sig figs. 2, 4, 5. 1, 2, 4. And we have 3. So it looks like our final answer should be rounded to 3 significant figures. So 4.7620 to the negative 15th divided by 3.8529 to the 12 times 2.183 to the minus 7 times 9.50. Okay, this gives me 4.62496357 times 10 to the 22nd, negative 22nd. And our units are going to be, so we have kilometers right here, which cannot be canceled out by any of the seconds, so kilometers. And we have the same units, and we're multiplying them 3 times, so that is going to be s cubed. And then for rounding, we just need 3 significant figures. So we have 1, 2, 3. So we're rounding to this value. So it's going to be 4.62 times 10 to the negative 22nd kilometers per second cube.